Hello and welcome back to Project Mastery Podcast. We'll be covering specific estimation techniques in today's episode. Let us start with one-point estimate. What do you mean by one-point estimate? When we estimate time using a one-point estimate, we are going to submit just one particular estimate. For the specific activity, we just go with one estimate. Example, this activity takes 4 days. This activity takes 5 weeks. This activity will take 3 weeks. This activity will take 20 days based on my prior experience. This activity will take 30 days based on my prior experience and based on historical information. The estimate could be based on expert judgment or historical information. It can also be a guess. This is a very simple quick method if you have the detailed information available or it's a straightforward task. And it is going to be very useful for low complex repetitive tasks. One of the disadvantages, uncertainty is not accounted here. It might encourage people to pad up the estimates because it's limited to just one point. When you say like this activity is going to take 15 days and it gets completed in 10 days, it can make the person who had estimated look unreliable. The risk and uncertainties are not covered here in this estimate. We'll move to the next estimating technique, which is called 3-point estimate. 3-point estimate is all about estimating in ranges. Things are not going to go as per how we have planned, and there may be a very small probability of ensuring project closure on a single date. You're going to give an optimistic estimate, you're going to give a pessimistic estimate, you're also going to give a most likely estimate for every activity. Uncertainties risk are being considered in this estimate. If the range between the optimistic and pessimistic estimate is quite wide, then that may indicate uncertainty and therefore risk is associated with the activity. Whenever you want to arrive at a risk-based expected duration estimate, you can go in for 3-point estimation. You take a simple average or a weighted average of the 3 estimates. Simple average is what we call it as triangular distribution. Weighted average is what we call it as PERT or beta distribution. O plus M plus P divided by 3 gives you the triangular mean. O stands for optimistic, M stands for most likely, P stands for pessimistic. O plus 4M plus P divided by 6 gives you the beta distribution calculation. Beta distribution uses weighted average and it's strongly considering the most likely estimate. When we talk about triangular distribution, we know that it's a simple average. It is giving equal weight to each of the 3-point estimates. Those who are writing PMP exam, you must be aware of these formulas. Moving on to the next estimating technique, we call this as analogous estimating, which is a top-down estimate. Expert judgment and historical information is used for this estimate to predict the future. Let's say for example the last 3 projects similar to this one each took 5 months, so this should also take 5 months. Analogous estimating can be used to calculate the overall project estimate. It can also be used at an activity level if the activity has been done on previous projects and there is a great level of accuracy as well as historical data to support the same. For example, the activity was completed in 2 days last time. Since we have no other information to go on, let us go with 2 days as estimate for this particular activity, and maybe we may need to review the estimate when more detailed information gets available. It all depends upon how closely the project or the activity resembles historical data. It's a quick top-down method for early project phases when details are limited. You are relying heavily on the similarity and the accuracy of historical data. Let us move on to the next estimating technique. We call this as parametric estimating. Parametric estimating involves a mathematical equation. It actually uses data from historical sources to create estimates. For example, lines of code. When you would arrive at a cost, it could be something like cost per lines of code. Parametric estimating can use scatter diagrams or regression analysis diagrams. These diagrams will track 2 variables to see if they are related, and then it is used to create a mathematical formula to be used for these kind of estimates. Apart from scatter diagram, learning curve is also used. Let's say for example, the 50th room painted will take less time than the 30th room because of improved efficiency. Heuristics is a concept which is also used during parametric estimating. A generally accepted rule, you can even consider it as a best practice. For example, design is going to be 20% of build. Design is going to be 5% of the project duration. Parametric estimating thus uses statistical relationships between the historical data. Data needs to be reliable and highly accurate, and the parameters need to be clearly defined. It should be measurable and scalable. Example, cost per kilometer of road, cost per lines of code. If 1 kilometer of road cost $500,000, then 10 kilometers is going to be $5 million. The time taken to paint a room of square feet of 1000 is going to take 2 hours. Then what is the time taken to complete 10 rooms of same square feet? It's going to be 2 multiplied by 10. 20 hours. So you arrive at an estimate based on these parameters. We have covered specific estimation techniques in this episode. We spoke about 1-point estimating, 3-point estimating, analogous estimating, parametric estimating. Every estimate has got its own advantages and disadvantages. Based on the current project situation, we apply the right estimation which is apt for the situation. We have come to the end of this episode. Hope this knowledge is valuable. Thank you very much for your time.